Okay, let's look at this one. Let's see what we have on this one. This is question 7 of Northwest question paper. In the diagram below, O is the center of the circle ABCD. A point on the semicircle such that ABCD is a rectangle. So if this is a rectangle, we know that the line of that rectangle, it will be perpendicular to the radius, which makes this to be 90. This one also to be 90. Okay, so ABO and OCD, those are your right angle triangles. So the radius of the semicircle is 6 units. Okay, so if the radius is 6 units, so OC, which is the radius, this line, it's equal to that line, because also BO is the radius, because it's line from center to the circumference. So this will also be 6. And they say the angle COD is theta. We can see that an AO and OD are equal. First question, write BOC in terms of theta. BOC in terms of theta. So let me quickly indicate which angle are they referring to. So if you want to understand the angle, you start from B, and then you're going to draw a line from B to O, right? A line from B to O. You move from B to O, then from O, you move to C. Then this is the angle that is between those two lines, is the angle that they are referring to. So this is the angle that they want us to find. So I'm not sure if you know that if I have a rectangle like this, we know that if I have a rectangle like this and I draw the midpoint of a rectangle, so if this is my A, B, the midpoint of that rectangle, when I say this side is equal to this side, then I draw a diagonal from this point to that midpoint, another diagonal from this point to that midpoint. I'm going to have by symmetry, this angle here, it will be equal to that angle by symmetry. So this tells you that this angle here is theta. So that's what I'm going to first tell the marker. I'm going to tell the marker that BOA, angle BOA, that it's equal to theta. And if this is equal to theta, the angle that they are looking for, can you see that we can use angles in a straight line to find that angle? So angles in a straight line end up to what? They end up to 180 degrees when you add them. So I'm going to say, therefore, I know that I'm going to name this angle that they are looking for. I'm going to let this to be X. So I'm going to let that angle to be X and tell the marker that if I take all those angles and add them, they should give me 180. Then you'll tell the marker that this is angles on a straight line. Okay, so now this will be 2 theta plus x. We are looking for x, right? It's 180, and we need to write that x in terms of theta. Therefore, what is x? X will be 180 degrees minus that 2 theta. And we know that this x is what? Is it's B angle OC. I hope you understand how we did that one. That was easy 2 marks to get. Okay, let me move to the next one and see what I can do from that next question. Next question says that if theta is 43 degrees, calculate the length of BC. Okay, let me go and look at my BC. This is BC. This is my length BC. So this is good because already if I have this length, this angle, and which is opposite to the side that I'm looking for, I can use what we call the cosine rule to find that angle. So remember, the cosine rule says that if we are looking for BC, so BC squared is going to be the sum of that the other two angles. So what I'm trying to say, not the sum of other two angles, but the sum of other two sides. So I haven't included angle, then I will add the side that gives me that included angle, which is BO and OC. I'm going to say this again. When you use the cosine rule and they want you to find BC, so BC will be equal, BC squared will be equal to, you first add the side that gives you that excluded angle, which is BO. So this will be BO squared plus OC squared. Then after, you have to subtract 2 times the product of those sides, which is BO multiplied by OC. Then this will be the cos of that included angle, the cos of the included angle, which is angle X. Then now you can just do the substitution. But remember, and we need to first find angle X if theta is 43 degrees. Let's quickly work on that. So I have theta as 43 degrees. I have to first find what is X. Remember, we said that X, this angle X here, we just said X is 180 degrees minus 2 theta. And now we are given theta. This will be 180 with minus 2 into 43 degrees. So I'm going to punch that on the calculator and see what is my X. So I'm just going to quickly punch this on the calculator, say 180. I'm going to subtract 2 times 43 and see what is that equals to. This gives us 94 degrees, right? So angle X is 94 degrees. So on that formula where there's X, we're going to sub in 94 degrees. So now let's do the substitution and see what we get when we substitute on that. What will be BC? So BC squared will be BO is 6. So this will be 6 squared plus also OC is a radius. That's 6 minus 2 into 6 into 6, the cos of 94 degrees. So I'm going to just punch everything there on the calculator and see what is that equals to. Wow, I'm having so much fun. This is an easy question, eh? 6 squared plus 6 squared plus 6 squared minus 2 into 6. And then we have into 6 again, the cos of 94. Right, I'm having so much fun. And if you are also, this is 77.022 next. If you are also having fun, please make sure that you follow the channel, subscribe to the channel so that you don't miss the next lesson. So the answer is 77.0224 and so on. Therefore, I need to square both sides to find my BC. So BC will be equals to, I'll go to my calculator and say the square root of answer. And say the square root of answer, that's 8.78 if you round it off, 8.78 units. That's BC. So BC will be 8.78 units. 8.78 units. Easy question. Right. Okay, so now on the last question, this is 4 marks. Let's look at what we have here. 7.3, it says that points A, B, C, and D are shifted along the semicircle. They want you to calculate the value of theta if A, B, C, D now forms a square. Guys, okay, let me explain why they are telling you that A, B, C, D forms a square. So I need you to think about this. What will happen if A, B, C, D forms a square? So I'm going to write down A. This is my A, this is my B, this is my C, and this is my D. So I have a point like this, and we know the properties of square, right? All sides are equal. All sides are equal. Therefore, if this forms a square, this tells me that AD, the line AD, it will be equals to what? The line AD is equals to DC. Okay, so the line AD is equal to DC. So they want us to do what? They want us to calculate theta, which is this theta. So to calculate this theta, I can use this side as my opposite, and then I can use this side as my adjacent, because this is a right angle triangle. So this is my Y, this is my X. So now the most important thing that you need to understand is that we are working with what? We are working with a square. And if we are working with a square, this tells you that my diagonals now, it will be AD. My diagonal, my adjacent will be AD. So look at my diagonal. So it will be AB. Then if this is AB, then I'm going to write this like this. So this tells you now this time AD, okay, let's say the line GC, or let's say OD. Look at this. Let me just write this down. the line DC is going to be equals to, because now remember, we are saying that we are forming a square. This will make DC, we know that DC is equals to what? DC is equals to AD. But now remember, AD is the sum of AO and OD. And they are equal. So this tells you that DC will be 2 times AO or OD. So you can say DC will be 2 times OD. This is where everything starts to be like more confusing. But if you really understand this, let's work on this. Let me try to explain this. So I'm saying that if A, B, C, D becomes a square, this side is going to be equal to that side, right? But remember, AD is the sum of, okay, let me write this down. AD, it's equals to the line AD. The line AD, which is from this point to that point, it's equals to the sum of AO plus OD. But AO and OD are equal, so I can just add this and say AD, instead of saying AO, I can say it's OD plus OD. OD plus OD, which makes AD to be 2 times OD. And we are saying that AD and DC are equal. So what is DC now? DC is 2OD. I think now you understand what's going on. And if we need data, I'm going to say that in that triangle, I'm going to say that in that triangle, in triangle ODC. So I'm going to write down for the marker to understand which triangle I'm working on. In triangle ODC, then I'm going to say that the theta, look at what I have. I can use my opposite because I have OD. I know what is DC. And then, yeah, I'm going to say OD over, I have opposite and adjacent. So according to SOHCAHTOA, I have opposite and adjacent. That will be the tan. So I'm going to use tan theta. This will be the tan of that angle. It's equal to tan theta. That's opposite. And what is your opposite? DC over adjacent. What is your adjacent? Remember, your adjacent is OD. Okay, your adjacent is OD in that triangle ODC. Then now I just have to substitute. I just have to sub in. This will be the tan of theta. It's equal to DC. We said DC, it will be 2 times OD. Okay, so this is 2 of OD over OD. Therefore, the OD cancels. I'm left with the tan of theta to be 2. I can find the tan inverse of that. So theta will be equal to the tan inverse of that 2. You just have to go to your calculator and say tan inverse and see what you get. I shift the tan of 2. That's equals to 63.43. So the tan inverse of that 2 is 63.43. Okay, so when you round it off, it's 63.43. So that's theta. So theta is equal to 63.43. So the most important thing for you to understand is that if ABC is now a square, this line, which is AD, it will be equal to DC. So now, since they are equal, we know that AD will be the sum of these two. Since it's a midpoint, all the other sides are equal, then use that to find AD. AD is 2 times OD, but we know that AD is equal to DC. So I need you to pause the lesson and try to make this work. Try to practice the question, and until you get it right. And that's it for this one.